Hey guys, welcome back to Critic Code. Today we're doing another Brainstellar Quant puzzle. This one is called shooting in circle. It's an easy problem. So basically what the problem states is that we have been given a circle where there's 124 pirates standing around the circle. And the situation is where we start with pirate number one. And now what pirate number one does is shoots the pirate in front of him. And then, so in this case, that would mean pirate number one will shoot pirate number two. And then, since the next pirate in line who has not been shot at yet, pirate number three, he would shoot pirate number four. And then pirate five would shoot pirate number six, and this goes on. And once one round is complete, by one round, so in this case, that would be pirate number 1023 shooting pirate number 1024. Once that happens, the circle is tightened because now there's only half as many pirates left, and the process repeats. And we keep on repeating this process until there's only one pirate left, and that pirate basically gets to survive. So the problem is to figure out which index or which position should we place ourselves if we were a pirate playing this game in order to guarantee our survival. So just to give you guys a few hints before coming towards the solution, one of them is to realize that since we've given the number 1024, and it's almost always the case whenever we've been given a big number, is that it's going to follow some form of pattern or some form of induction or recursion. What we have to do is think about a very simple case. So, and 1024 is basically 2 to the power 10. So solution, and also since we're talking about pirate shooting every alternate pirate or shooting the pirate in front of them, right? So you can start to get a feel of binary numbers and binary patterns and how that might help come towards the solution. So, and another thing is, yes, so since this is a very large number, you might try to think about a case where there's only one pirate, or there's two pirates, or there's like four pirates, or eight pirates, or 16 pirates. You might start to see a pattern, and you can just use induction to think about the case where there's 124 pirates. First of all, think of the case where there's only one pirate. Well, in that case, since P1 is the only pirate, he's going to survive, right? Now consider the case where there's two pirates. What happens in that case is P1 kills P2. So we end up with pirate 1 surviving. And what happens in case of four pirates? And by this time, I think you guys have started to come up with at least a guess for what's the answer. So in the case of four pirates, pirate 1 kills pirate 2, and then pirate 3 kills pirate 4. And then there's only pirate 1 and pirate 3 left. So pirate 1 kills pirate 3 in the next round. So what happens is pirate 1 again is the only one surviving. So since we've established a few base cases, actually even this in itself would be a sufficient base case, but I still wanted to go over a few more cases. So what we start to notice is that, and if I were to ask you the question, let's say I had 8 pirates. After one round, and we know that after one round, 4 of the 8 pirates are going to die. Actually, all those pirates that are on even indexes, right? From P2, P4, P6, and P8, all of them are going to die because the odd number of pirates will kill them. We know that the number of pirates is going to halve every round. Every round, the number of pirates halves. So after 8 pirates, we got 4 pirates. And now what happens is, this case is almost identical to this case over here, where there's 4 pirates. So what I'm trying to get at is, when we have n pirates in a circle, and here n has to be a perfect power of 2, so 2 to the power x. So I mean, for the case of 8 pirates, x is basically 3, right? What happens is the number of pirates after one round halves, right? It becomes 2 to the power x minus 1. And well, just to be technical, we notice that all the pirates that were on odd positions are the ones that are left. But effectively, it is the case of 4 pirates, right? It's just that over here it was P2, over here it was P3, and over here it was P4. But ignoring that, we know that these 4 pirates are now going to have the same situation that the pirates had in the case over there. And we learned that in that case, P1 was the one who survived. So since we know that P1 survives in this case, we could deduce that P1 is going to survive in the case where there's 8 pirates. Now I could say the exact same thing for 16 pirates. We know that at the start, P1 is obviously going to survive, and he's going to reach the case where there's 8 pirates. And we know, since we just deduced over here, that P1 survives when there's 8 pirates. So we can say that P1 is going to survive when there's 16 pirates. And the process just keeps on going until we reach 2 to the power 10, which is 1024. And we can deduce that P1 is going to survive. So this is the official Brainstellar solution on the website. And it is pretty similar to what we just talked about. It's over here, it's given in a lot more formal mathematical notation. Basically, it uses mathematical induction, and it says that for the base case where there's only 1 pirate, we know that P1 is going to survive. And now coming to the inductive step, it says that we're going to assume that for 2 to the power m pirates, P1 is going to survive. And now we try to prove that for 2 to the power m plus 1, which is twice as many pirates, P1 is again going to be the person who survives. And we deduce that by saying that for this case, since all of the even number pirates die, and we come to the case of 2 to the power m, all of the odd pirates are surviving. That is going to include P to the power 1. And we know from this point onwards, P1 is going to survive all the way, because we had that as a inductive step over here. So this means that it's also, the inductive step is also going to be true for 2 to the power m plus 1. That's a basic overview, but I would still recommend you guys pausing and going over the formal solution over here.